have them in L1, Earth Moon L1, Earth Moon L2. And as you can see from the measurement here, and this goes to the center of the moon, it's within the 75,000 kilometer window or horizon. Okay? So here would be some advantages of human-controlled telerobotics. Basically, the big advantage is telepresence, real-time or near real-time telepresence on the moon's surface. Okay, but you see these other things: near continuous illumination, line of sight to the Earth, low cost of orbit station keeping. You would need a little bit of station keeping in this particular orbit. Okay, low energy transfers to other L points, and we'll talk about that when we talk about the gateway. Here's the bean-shaped orbits around Earth, Moon, L4 and L5. And by the way, this is how it would look if you were hovering above L5, right? And this goes out 90,000 miles, 145,000 kilometers around, more or less around this. But of course, this is all dynamic, and looking at, if you were hovering above the Earth, it would look like this as it goes around, following the moon. And of course, L4 would proceed. Okay, these are the Lissajous orbits that were used recently by the two Artemis spacecraft. Here's a really interesting one. T.A. Heppenheimer, his proposal, and there's something about this I don't understand, maybe somebody can explain it to me, but when he was looking at a good place to put a habitat, or like a mini biosphere rotating in space where thousands of people could live, a la O'Neill, or something like that, or some of the other ones that have been proposed, the O'Neill cylinders and so forth. He said, no, L4 and L5, it takes too much propellant to get to those. It turns out that if you just put something in L2 of all things, L2, and you just leave it alone, the darn thing drifts through the magic of orbital mechanics, little by little, it'll drift over and just start going into a 2-to-1 resonant orbit, or around the Earth, Earth-Moon resonant orbit, and it will just do that forever without any propellant, according to Heppenheimer. If you want to go a little, it would take a while for this to happen. So if you wanted to do this quickly, you would, give it a little boost here and there. Yes.
If that's a stable orbit, why don't we see any asteroids?
Debris in it?
Yeah. You think
I don't know.
millennia sun wrote a sun in there?
I don't know.
So I'm guessing it's.
Why don't we see debris in L4 and L5? Those are stable orbits. Do we? Maybe we just haven't checked them.
I think people have looked, and if it's there, it's a tiny little small threshold. It's not detectable.
Yeah. I don't know the answer to that. Maybe somebody. Here's another thing that I wonder about. Let's say it's metastable. Let's say it's metastable. In other words, you need a little station keeping. What I don't understand are the sharp turns, how that can happen. Boom, boom. If somebody here knows the answer to that, let me know. But Heppenheimer.
It might be because it's a relative position and not really fixed in space.
That's what I think.
Yeah.
That's my theory. But anyway, so John S. Lewis, and by the way, I brought these books in that bag there. But John S. Lewis loves these high eccentric Earth orbits. They're not all resonant orbits, but what he maintains about these orbits, and they don't necessarily have to be used just for habitats. Perhaps you could have a staging site there or something else. What he makes a lot of bones about with regards to this kind of an orbit, and when I say this kind, I mean this one, goes all the way out to lunar spaces and back, and it can go very close still to low Earth orbit. What he says a lot about this is that it's easier to get to one of these and go to the moon than to go to geosynchronous orbit, because you don't have to circularize the orbit, and that takes another kilometer per second in delta V, or change in velocity. And then most recently, Anzaldua came up published a paper, and I don't know if you're all familiar with him, but anyway, he's an independent astrodynamic software consultant. Previously worked for NASA. He came out with a paper showing that what he calls selenocentric, in other words, moon-centric, distant retrograde orbits can be stable. If they're retrograde, they're more stable than if they're prograde. They can be stable from 11,000 kilometers all the way out to 68,000 kilometers. That's remarkable, I think. You know, you've probably heard, don't get too close to the moon because of the magnetic fluctuations and low moon orbit. It won't last very long. Yet you can get this close to the moon if it's retrograde, according to him. Now, we're not going to go into this. We don't have time for this, but you'll see that cycling orbits is something also that Buzz Aldrin talks a lot about, and he's been talking about it for years, and he was involved with the submission to the Augustine Commission, and and at that time he was pushing these Earth-Moon cycling orbits and showing how they would fit into even Mars missions to the Mars surface. And since then, he's written this book called Mission to Mars, which I have a copy of, and I can show you. And he really goes into getting into various Earth-Mars cycling orbits. And he says that if you have a pair of these cycling orbits coming, even though it would take a year and a half for the cycling orbit, for a cycle to occur, if you have a pair of them, you can have a 6-month portion of one orbit going to Mars and a 6-month portion going back to the Earth. So why don't we just put what's the big deal with telerobotics? Why don't we just put humans on the surface? Well, I think we all know why, and I'm not against seeing humans on the surface. I can hardly wait. But it's expensive and problematic for these reasons. This last one here, dust from hell. This dust is terrible. It clings. The astronauts who have been on the moon do explain that the dust is, first of all, it's all sharp-edged, and it clings to everything. It's really a terrible, terrible problem. And this, of course, would be very, you got radiation, gravity, you have lots of, and it's expensive. You have a lot of problems with that. But you can put human cognition on the surface. Anyway, human cognitions and dexterity, yes, sir? Yes.
I recently read a book on vacuum engineering.
Yes.
And it talked about filters that are now available commercially, which can handle the kind of particulate that's on the moon, even though they were a major pain in the past.
Yeah.
With this technology, they don't have to be.
Oh, okay. That's really good
There's
to know.
some real advances in vacuum engineering.
Fantastic.
And
Now,
I don't have the
would that help outside of the space habitat?
It would prevent you from bringing dust back inside, unless you were collecting dust as a sample.
Yeah, got it. Well, it's really good to know. Do you remember the outfit or the company that produces those filters?
If you give me your business card, I'll email it to you.
Will do.
I don't have that info with me.
Will do. Thanks for that input. Okay, so basically, we can get lunar development started we can actually put human telepresence, through telepresence, we can get it started, and we don't have to do it with this 2.6 to 3 second delay. We can do it from Earth Moon L1 or L2. Huge advantage. Huge advantage. Same way it goes for Deimos and Phobos vis-a-vis the Mars. Okay, NASA has proposed Earth Moon L2 gateway. Great idea. Who knows if it will be financed, or we'll get enough resources for it. But it's a great idea, I think, because that gateway can lead to a lot of other possibilities and locations. Here are some significant delta V's. As you know, the big jump is from Earth's surface to Leo. Even though, let's say if you get to Leo, 600 kilometers, this is fairly stable orbit. It'll take a long time to degrade. So you can get up that high. That'll probably take 9.8 or so kilometers per second just to get there. So close to 10. So, I mean, that's a huge jump. And I think it was Heinlein that said if you've made it to Leo, you're halfway to any place else in the solar system. So this really illustrates that. Leo to Geo, 4.3. Okay, Leo to Earth Moon L1. Look at this. What do you know? It's less than to go to geosynchronous orbit. Leo to highly eccentric Earth orbit. Same way. It's even less. Okay, now these are, it depends on the type of trajectory and whatever. I mean, but these are just sort of basics. Okay. Earth Moon L1, L2 halo orbit to near Earth asteroids. Okay, this would take some time, but it's very, very low. Delta V, change in velocity. Everybody understands delta V and change in velocity, so we don't have to.
I used to know what it meant.
Well, basically, it's the in order to get to another, using the rocket equation, in order to get, it's how much more about velocity you need to get to the next step or next destination.
It's really annoying to have this ancient tech foisted on us when we could be riding around in saucers. Thank you.
Right, well, I don't think you're going to get any arguments. All right, so as you can see, the Earth Moon, once you get to Earth Moon L1 or L2, okay, you can go to all these different places. And with aerobraking and aero capture, you can even get to Mars very, very cheaply in terms of propellant. It would take a long time because of Mars' thin atmosphere, but if humans weren't on board, you could do it through aero capture. Okay, now the difference between aero braking and aero capture, I guess it's a fine point, but aero capture comes in, what is the word they use? Parabolically. It comes in and it goes very deep into, this is when maybe it's robotic or telerobotic, with a heat shield vessel, comes in very deep, very close actually to the body, and comes in parabolically, and then goes into orbit after that. It gets slowed down drastically. And the Earth's atmosphere is much thicker, it works much faster. Okay. Aero braking just is a more general term. It could be just skimming the top of the atmosphere. So that's basically the differences, at least as I understand it. So aero capture saves propellant. That's the point. And again, Earth Moon L1 or L2 to high eccentric Earth orbit. Wow, 0 if you want to take your time from L2, or if you're coming from L1, it costs a little more, but look at that, meters per second. What is that, about 20 miles an hour or something, change of velocity? And one thing to keep in mind too is that the interplanetary transport network, which is a gravitational pathway connecting the Lagrange points, once you get to the Lagrange points, if you have a cargo vessel and you're not in a hurry, you can get on this highway, as it's called, interplanetary highway, and with very little propellant move around the solar system. So, yes, sir.
I was an avid science fiction reader of Dr. Robert L. Forward's books, and I had sent him an email praising his books, and he actually called me up. I was shocked.
Really?
Yes. I guess my praise was so excessive that he couldn't ignore
Couldn't
it.
resist.
Yes, but he was actually, he called me because he had been a lieutenant in World War II in the Army, and he saw that I was also in the Army, and he was an amazing writer, not just of science fiction, but in the last years of his life, as he told me, he was working on the solar system choo-choo, the solar system train that would take us all over the solar system using tethers.
Oh, yeah.
He was very big on tethers,
Mr.
Yeah.
Feathers.
and I'm still wondering who cut the tether on the astronauts' NASA mission.
Yeah, yeah, tethers actually can be used also, or proposed to be, is one of the ways that removing space debris can be done.
He
Actually,
started a
through
company,
tethers.
Tethers Unlimited, that
Yes.
still markets that device.
Oh, interesting.
Well, more to the point.
Yeah.
I mean, I might as well jump in. I thought a Japanese company, and I forget their name, was about to, or is testing.
Yes, they got stuff.
A mech.
Right now,
Very
we're
soon,
about to
yes,
come up,
yes.
I mean, to actually
Yeah.
test the tether idea on the lunar
Oh.
junk. So their idea is.
Oh,
if they
lunar
could-
junk? Excuse
I mean,
me.
I said lunar junk, Earth orbit junk.
Oh, yeah, debris?
Yeah, in other words, that their
Yeah.
idea is that the tether can be used to decelerate,
Yeah,
you know,
Yeah,
and
there are various
either by
ways.
its drag. If
Sure.
they can get an attachment and then, I mean, without having the big grapper or the Swiss
Right.
thing or whatever, that you can do it.
yeah.
So,
Well,
I
you
was
can do it
thinking-
with lasers too. That's a longer discussion though. But the Japanese also have this net idea,
Sure.
you know, you just stand in
Well,
the
that was,
way.
again, that's more like the big grabber thing. But,
Yeah.
all right, well, since brought up the tethers, it just linked back into the talk that there at the beginning. And the other thing I was thinking, if you're presenting this to an NSS audience,
Yeah,
a lot of whom have some linkages back to the L5 Society, that maybe need to add on that chart of telepresence distances, add the L4, from L4, L5, what the range might be to make the
Yeah.
argument. Because I know, if I'm remembering correctly, it wasn't on the list. You were asking for input, so I'm being very.
yeah,
glad
no,
to
no, no,
give
thank you,
some.
thank you for that. I explained why it turns out it's outside that 75,000 kilometer.
Correct. And
But
I
that would
think it's
be
an
good to
important, it's an
explain.
important point to explain why NASA is suddenly talking, they're talking L2 instead of L1. I mean, but they haven't really explained to a lot of folks why they're giving up on L4, L5.
Yeah, good point. That's something I can add very quickly. By the way, it was in regards to that, so why 75,000 kilometers? You know, think about this. You want, you know, the speed of light is 300,000 kilometers. Half of that is 150,000 kilometers. Half of that is 75,000 kilometers. So if something is 75,000 kilometers away, at the speed of light, it gets back to you in half a second. It's a quarter second to get there, half a second to get back. If it goes beyond a half second, problems ensue. It becomes exponentially more difficult to do anything, you know, these fine manipulations in particular. So that's why there's that horizon of 75,000 kilometers. And L4 and L5 are outside of that when you're talking about you know, a lunar something happening on the moon. So good point, and something I will explain. There are a lot of L5s, including myself, in the you know, involved in space still. Okay, so we don't need to go into this, I don't think, but you've probably, all of you have seen the different schemes. You know, John Strickland, for instance, has written several articles about what would be in, what cis-lunar infrastructure would entail. So you can read that for yourself, and we can move on. Okay, one other idea is to have a far-side telescope, and that would be part of cis-lunar infrastructure. And if you look at this, I'm running a little behind now, so I'm gonna skip around a little bit. But basically, it says crew gathers information needed to finalize the telescope deployment plan, and you see this little rover. Well, how's that? It doesn't say telerobotics there, but how's that rover moving around? If it's from a place from L2, if you're in a halo orbit, it's moving around very well and very nimbly. If you're doing it from the Earth, it's ponderous. Okay, so here's the rationale. I think anybody can see that on the far side of the moon, we would have shadow free of radio waves. Okay? There's some problems with that, but we don't have time to go into it. Okay, here's another small step towards cis-lunar infrastructure, I think. NASA called for $100 million for a mission to capture a small asteroid and bring it to the vicinity. Now, I don't know if this is still viable. The new NASA budget has come out. I heard just on the way here, David Dunlop called me and said, "Oh, did you hear the new ad that NASA has just initiated a commercial program for or a program for a commercial rover on the moon."
Yeah, that's good.
Isn't that good?
Yeah.
Yeah. Yeah, David Dunlop just told me about it. So I look forward to reading about that. Okay, propellant. Okay, so where will it come from? By now, everybody knows, or all of you folks know, that there are billions of tons of metric tons of ice on the moon in cold traps in the polar regions, North and South Pole.